Okay, so welcome everyone. Welcome to the AWS Security Group West Africa, another learning session. We're happy to have you here. Another awesome weekend of learning. I hope you're excited as much as I am. I'm excited to learn. Falasha Days, I've seen her profile, and yes, it's going to be a fantastic learning session. So if you know somebody that is supposed to be here, that is not yet here, please reach out to the person. The person needs to be here. So we're going to give them about 5 more minutes to join us, and then we are going to introduce our facilitator and just get started with what we have to do for today. All right. So welcome once again to the AWS study series. All right. Okay, so I think we can start now. Hi Kunle, hi Emmanuel. Glad to have you here. It's okay. Please confirm you can hear me clearly and you can see me as well. Can we hear me clearly?
I can.
Okay, all right. Thank you. Okay, thank you for Lashadi. All right. So, once again, welcome to the AWS Studies series. My name is Christiana Dada, and I'll be anchoring today's. Say again. Flashadi, I didn't get that. Okay,
Oh no, please
so
go
let's
ahead.
all right. So let's start. Like I said, if you know someone that is supposed to be here that is going to benefit from today's session, please share the link. Let them join. Today is we are learning about deploying scalable apps with EKS and Karpenter, right? If you're familiar with auto scaling and container orchestration and all of that. Today we're going to learn how the AWS EKS and Carpenter like kind of gives you this powerful force in container orchestration and auto scaling. So I'm so excited to learn. I have my notepad here. I hope you have yours as well. And shortly, we are going to be bringing up our moderator, Folashade Oroge. And honestly, I can't wait for everything she has for us in this session. Okay, so today we are looking at deploying scalable app with EKS and Carpenter. So one of the most important things for startups is that they want to be able to scale and not just scale, they want to be able to scale large, right? So how do you scale without that operational overhead? That is what you're going to be seeing with EKS and Carpenter. And as a DevOps engineer, you're going to be learning how to use the AWS Elastic Container Service and the Carpenter, which are two powerful services from AWS for container management and auto node scaling, right? So please share this link with your colleagues that are supposed to hear, with someone you know is supposed to be here. Let them join. We're about starting in about a minute. All right. So shortly, I'll be reading the profile of our facilitator. I just got to know about Folashade today. And funny and interestingly, when I was reading about her profile, I was like, this is mighty. So yes, we have someone here that has walked the walk, not just only talked the talk. She has been in DevOps, she has been in this space for quite a while. So yes, you're not just learning from someone that is just saying, but you're learning from someone that has walked the walk, right? So she's going to be giving you practical steps on scaling and container management. So it's 6:10 now. So I think I'm just going to read Falashade's profile so that you will know why I'm excited for this session. All right. So Folashade is a cloud and DevOps engineer with over 5 years of experience designing, deploying, and managing scalable cloud infrastructure. Her journey in tech began at the help desk as a help desk engineer, progressed through cloud support engineering and systems administration, with roles at Flour Mills of Nigeria and Tech Knowledge, giving her a deep practical understanding of how infrastructure works at every layer of the stack. So beyond that technical work, Folashade is a recognized leader in Nigeria's tech community. She served as a chapter lead for She Code Africa, Lagos for 3 years, earning an excellence award, earning an excellence award for outstanding contributions to the chapter. She has volunteered extensively across SCA Lagos, Women Tech Maker Lagos, GDG Lagos, and several other tech communities. She currently serves as a mentor at Tech for Dev and a DevOps trainer at Spice Tech, where she's actively shaping the next generation of African tech talent. Folashade is also the recipient of a leadership award from Daystar Academy, a testament to her commitment to people development and building. As a seasoned event organizer and host, she has brought together developers, engineers, and tech enthusiasts across multiple platforms and stages. She's currently building a startup called Event Hub, a digital vendor marketing marketplace management platform designed to streamline the discovery, verification, booking, and management of event service providers across Nigeria. So I hope if at the end of this, what I've read to you, you are not excited, then I would like to know why. But I'm really excited to learn from Folashade. And I'm going to be bringing Folashade on the stage now to take us through the the topic today. But just before I bring up Folashade, I'm going to be going through a couple of housekeeping rules. We are You can drop your questions on the chat when it's time for Q&As. And while Folashade is taking us through the study series, I'd like us to have our notepads, jotting things down, and jotting your questions, of course, because we might not be able to take questions at the point of her taking the session. But of course, there's going to be a Q&A after the session. So just jot your questions down so that we can take those questions during the Q&A. So that's just something you need to know. And of course, um, you can still invite more people. The session is just starting. So before we get fully started, before Folashade comes up on stage, please ensure that you are magnanimous enough to share this link with someone that needs to be here. All right. So thank you so much for joining once again, and I'm going to be bringing Folashade on the stage. Hi, Folashade. Over to you.
Hi everyone, good evening.
Good evening.
All right. Oh, great. I believe you can see my screen, right?
Yes, we can.
Please confirm what you can see.
The slide.
Okay. All right then. So good evening, everyone. My name is Fola. Thank you so much, Christiana, for the introduction. Truly appreciate that. So there's not much time. I think we have just less than 45 minutes to run through a whole lot of things regarding the topic that was given. So, um, right. So let's get started. So today we're talking about how to deploy scalable app with EKS and Carpenter. And since we already know that so I believe that everybody is not a beginner or maybe how do I put it? They already have information or have good knowledge of what an EKS should be. So I won't be doing all those like explanations of what EKS does, blah blah blah. So we'll just get right into the Carpenter itself because I think that is like a new feature that was released I think maybe 2 years ago or I think last year. That was when I got to like know about it and implemented it. So right. This is also, like I said, not a beginner class or maybe let's say intermediate, but I'll break it down to a very good extent that anybody that is learning or just starting their career or are able to like understand or get carried along the way. So what we'll cover today in today's section, we talk about scaling problem, the EKS architecture, the carpenter itself, how the lab what you should have for your lab prerequisite, and some cost optimization regarding carpenter and some hands-on. All right, so I think the first question will be that okay, what is carpenter? Um, I wouldn't want to. We already have like most of the definition written on the documentation on Carpenter itself, or maybe written by AWS or Carpenter itself. But anyway, in a short form, it's more like able to for you to be able to manage your auto scaling. So we have like the traditional way of doing auto scaling with your infrastructure, and you're wondering how to do this in more efficient or maybe seamless way than the traditional way of going about it. And so today we'll just see how how modern Kubernetes workload can scale automatically and how cost efficient on AWS without actually manually um, managing your infrastructure. So maybe it's a beginner friendly. So let's just go right into it. So we'll start with the part that in the scaling process. Um, Let me go right here. So how traditionally scale falls short. So before we get right here, the scaling problem that most teams face in Kubernetes, I believe you can still hear me right. Let me just confirm that before I before I get right into. Am I still audible? Right? Oh, she's not so audible. Okay. Christiana, can you please confirm if you can hear me? Um, Christiana, are you still there? All right, thank you. All right, let's. I just want to assume that it's just one person that can hear me. Maybe their audio, but if everyone can, Christiana, if you can confirm that, I think that we are good. Your slide. Um, my slide. What happened to it? Okay, yes. Okay, let me just stop sharing so that um we can take it again. Okay, I should make the slide in a slide mode. Oh, right. Okay, good, good thing. Okay, so is it better now? We can't see it. Okay, I think that's some sort
Okay,
of
you're not
clash.
sharing your slide again, so maybe you might want to bring up your slide again. We can't see your slide anymore.
Um, what about now?
Not yet.
Not yet. Okay, this is
Um,
true.
all right, so I think it's coming up now. Your screen is coming up again.
Okay.
Okay.
What about now? Is it better?
Yes, maybe you should put it on presentation mode so that
Or you can see my slide now, right?
yes, you can.
Okay. All right. So let's. All right. Okay. Are we good now?
Yes, perfect. Thank you.
Okay. All right. Okay. So I was actually saying that we'll start with the scaling problem that we mostly face in the Kubernetes, or let's say the EKS architecture, how Carpenter sort of solve that scaling challenges and how we can actually like do hands-on deployment flow. So at the end of this, we are able to discuss how the cost optimization strategy should like go, because scaling is not just only about the performance, but also how to like reduce like cloud spend. So this is how. So we are just this slide just shows how some of the what it falls short and how Carpenter sort of is more better and advanced. It's on the slide you can see it's when it comes to provisioning, it's faster and it reduces cost. There are different instance type you can actually like use. and it's also able to manage or have an automatic spot handling, and you don't have to like what that means is you don't have to like manually start what's it called, creating or deploying an EC2 instance, a spot EC2 instance. You don't have to start doing that manually, but it has to, Carpenter does that work for you efficiently without you having to do anything on your hand as long as it has been configured. So, yeah, it's an exact fit. So, in this what's it called, architecture that we're currently like having. So, let me go back a bit. I think we should see something here. Okay, so traditionally in Kubernetes, teams sort of create fixed node groups is ahead of time. So you see people like deploy their node groups ahead, fix it. I mean, they are actually like fixed. You have like some specific node groups that have been stated. So the problem is that the traffic is very unpredictable, especially when they have like let's say when you actually have like um you have what shall I use right now? Give me a minute. For example, you have maybe I lot of I what's it called now? You have a lot of people trying to access your website at the time, maybe, and the load that you currently like have is not enough to carry what you currently like have deployed. So it means that you have either because you want to not have those challenges, you have to have many nodes like applied to your clusters already. Maybe for example, you need five, and because you're not really sure of when there can be spikes or there can be scaling issues, there could be maybe workloads, so many issues coming up, then you have to like have more than enough. Maybe for example, let's say 7 out of 5, and because you're not really not starting, and those sort of things give sort of waste money, and if you don't have that enough nodes available, that means you have to like have maybe few nodes, and that will also mean that apps could be down. So in these situations where we have maybe too many nodes deployed or too few nodes not deployed, these two things are issues, because if you're thinking of, oh, let me have few nodes, it means that anything can happen when you have like a whole lot of high um, people coming on your website. So in that case, Capital sort of solve all of these issues, and it's changed the model completely. It's in the way that, so let me go back here. So on this architecture now, let's say that a pending pod means, let me run through here. So let's work on how Carpenter works. So that I'll come back to that on architecture. So in, for example, how Carpenter works, the provisioning pool, it sort of means that it detects how unshadable ports due to insufficient cluster capacity. It helps to run the application, but there's no available nodes without enough CPU or maybe memory. So provisioning in this sense means like maybe creating your infrastructure automatically, and in this sense, including what we have here as well, spot instance. It means that maybe unused maybe AWS compute capacity are sold or at discounted prices. So we won't like be going into details of, oh, what is spot instances, um, what is what's it called, pod, and all of those terms that are used in AWS, because like I said, it's not really going to be much of beginner classes for it, for those that are actually listening. So in this sense, Capital sort of watches or controls how the pod requirements are done. So it includes, which includes the CPU, the memory, and the spot. It controls the memory itself, the CPU. It lets you know exactly. So it sort of selects from over 700 EC2 instance type. And I know that on the manual traditional way, we sort of put a particular instance type that we want to like use for our node groups. But in this scenario, Carpenter does that. It selects the best one out of it. It sort of looks for the best workload or the best particular EC2 instance or instance type that is going to be usable at that particular period. And when it's it boots and joins. So for the number four, it boots and join the cluster via bootstrapping, and in less than 60 seconds, it's actually like hop. So it's way very faster when using Carpenter, unlike the traditional way where it has to like take a longer period of time to do all of those scaling down, then trying to get a new one up. So Carpenter binds the pending pool to the freshly registered node in a very short very time as well. So this is where the pod gets scheduled, and in less than and for the number six, it says Carpenter continuously right size and terminate underutilized nodes to cut cost. In this scenario, it means that in when they are actually maybe there were high number of people using the website, and now it has gone back to maybe the normal usage that you use on your website on a particular day. So when things like that happens, it's just stream down, shut down or terminate those node groups instantly, and you don't have to do that by yourself. It does that by itself, and it's all those unused capacity and node groups are actually shut down immediately to like cut cost, and that is where the cost spending comes in. So all right, I hope I'm not just too fast, but right, I don't want to be too fast as well. So the process of us doing running through our Carpenter works, it makes sure that a pod is detected, and also it's you make use of the SQS as well. Right. So we're going to be looking at how node pool and EC2 node pool and EC2 node class works in the Carpenter. You know, there are times when previously that we usually will have what's it called now? The traditional way of doing node pools and EC2 node class. And I think previously node pool was like provisional. I, I didn't really know much on that. Provisional was like a whole time thing. But anyway, but right now we're now having node pool and EC2 node class being used in Carpenter, even across on EKS generally on itself. And EC2 node class sort of sets the AMI family, the subnet selector, the security groups, instant profile, and all of those things. So you when Carpenter is selecting from over the 700 EC2 instance type that we have, it just randomly pick the best one, and what's it called? So for example, we're using like AMI 2023, it just picks the ones that fit best according to your workload for that particular time. So going back previously to this, we'll now say before Carpenter, many terms use cluster autoscaler. And how do I say? So in the way cluster autoscaler works, it sort of predefine our node groups, but it's slower and less flexible because it sort of depends on autoscaling group. However, if your application suddenly like gets traffic and or gets traffic spikes or waiting for about 3 to 5 minutes for the node, it means user may experience like latency or slowness or downtime depending on how crazy the spike is. So in order to like avoid those outages, team now usually needs to like get extra nodes running all the time, which is actually cause which actually increases cost. So now, yeah, that means you're going to be like paying for servers that you are not actually using. And so that is why the campaign that now exists. It helps to let know that okay, you can actually do more without actually increasing your cost. So I'm going back to the now. So back to the architecture that I actually skipped earlier. So now we need to run through everything. Everything runs through a VPC, like we all know on EKS. And when you have all of this in an on your cluster, I mean your EKS on being connected to the VPC, EC2 instances, your private subnet, all of this is just a normal way of how you would have your architecture done depending on how wide your architecture could be. So now I'm not like talking about large architectural diagrams that every organization should have, but this is more like a minimum of what how the Carpenter EKS architecture should look like. So the load balancer is usually like in the public subnet because it needs like the internet access, and the worker nodes are usually placed in private subnets for security. Sorry, let me go back to that. So, and when you the private node uses a NAT gateway, they need to like have like an outbound internet access. For example, maybe to like pull container images, right? So that's why, and the other part we have the let me be moving my cursor so that people can follow along with me. So the other part that where we have the control plane, it's more like being managed by AWS. So there's really like nothing much to say here. So the Carpenter nodes are like the EC2 instances that are dynamically created by Carpenter. That's like the simplest way I would like want to like define it. So back, um, I know that when a developer like deploys an application, the cluster doesn't really have enough capacity. So that's what like the pod pending means like. And in situations where Carpenter needs to continuously watches the Carpenter scheduler for unschedulable pods. So this could be the CPU or the memory or the architecture or pod instances as well. And in Carpenter, node claim is very, very important because it needs to be created. It's like the internal request objects representing like a node that should be created. All right, so it's sort of Carpenter intelligent sort of pick the best EC2 instance type at that particular point. So I just hope I'm not confusing people because though it's very simple and it helps to like scale out on all the necessary parts that is needed for your deployment or your application, because of the manual process is going to be totally like maybe eliminated to a very certain extent. All right, so now going back to here, and like I mentioned, these are the two important parts of key concept of Carpenter, the node pool and the EC2 instance. So I'm not really going to like touch much a lot on this since we already like discussed earlier. So right, so the prerequisite that will be needed for the lab. Let me check my time. Oh shit. Okay, so the prerequisite that will be needed for the to deploy this is you'll have your AWS CLI, EKS, sorry, please excuse me. So we have the kubectl, or JQ. Some people might need it, and obviously your AWS account, right? Some people would prefer to like set their environment variable depending on maybe create a particular file for it, just to state. So let me go back a bit. There is a particular what's it called documentation that I would like us to like use, where for example I would expect that many people that want to like switch or maybe migrate to Carpenter are obviously like using cluster autoscaler previously, and in order to be able to do that, that's the process that we are going to be like going through today. Okay, right. So this means that you have like an existing what's it called, EKS cluster, VPC, and just like you've seen on this documentation. So we'll run through most of the steps that that's what we'll be implementing later in the section. So going back, right? Okay, so let me go back to this. All right, I believe my slide is still can still see my slide. All right, so we're not going to be creating a cluster on the call anyway. So I believe that many people have like an existing workload previously. So if you're going to be doing like a migration, that means you have some of those things installed, and you are obviously maybe using a cluster autoscaler, and you want to like migrate to Carpenter. So when creating a cluster could take about 15 to 20 minutes, but yeah. But anyway, so how to install the carpenter parts. You can either use him or you can either use what's it called, kubectl, to do the installation, and it's very simple to do. Let me run through. So usually many people use M to like deploy this. So we're going to like run how we are going to be doing this. Also, please, I mentioned earlier that we're going to be using SQS, interruption queue, which is very important in Carpenter, because that SQS is going to be like the I am rule, so that your clusters can actually receive EC2 spot interruption notice, and then can now proactively drain those nodes when they are actually being reclaimed by AWS. It's sort of like a maybe a notification to like tell like Carpenter that okay, this needs to be reclaimed and all of that. All right, so I'm almost at the end of my slide, and right. Okay, so we're going to be like doing a little demo of how the slide thing should work. So before we now come, okay, let me take the last important part before we move to the demo part. So when it comes to cost optimization on Carpenter, so for example, you already like deployed Carpenter. What is the usefulness? What is it like? What will help with the organization of your infrastructure? For example, first off is the spot instance, the ability to be able to like create a particular EC2 instance that is needed and maybe drain it when it's not like needed again. So yeah, it's very good. It helps to like provision like a spot pool and reprovision it on automatically. Then also the consolidation part, the savings plan, right size, and picking up the right size for your particular workload. It checks the right part. Those are like the part of the right features that I would say Carpenter helps to like make use of. Okay, all right. I think I was talking too much and my voice is already like dried. All right. Please allow me to share my screen. Okay, all right. So, um, sorry, let me see. It's please confirm. Okay, all right. So, I this is like an EC2 instance that I created. Like, give me a minute to load this. Ooh. Christiana, please confirm how many more minutes I have. Okay, so anyway, I can hear her, but so I'll just continue. So, I quickly deployed a cluster yesterday. Was it yesterday? Yeah, yesterday night. So it's currently like using a version 1.34. Sorry, I need to like share my. So we have a repo that I created like EKS Karpenter demo, which I just deployed um, earlier today. So it's using Flux as the Git operations, and we'll be using EKS and how then we can now implement what's it called, Carpenter running on it. Sorry, give me a minute. Right, sorry. Okay. Please confirm you can actually hear see my screen. Hi Christina, can you hear me?
Hi, I can
Hello.
hear you. Sorry about that.
Okay,
Can you
can you
hear me?
see can you see my visual still? Yes, I can hear you now.
No, we can't see your screen anymore. It's not sharing.
I stopped sharing the slide screen, so I'm trying to move to my terminal. What about now?
Not yet. Um, well, I can't see it. But,
What?
I can't see it yet. I can't see anything yet.
What about now?
Hmm. Okay. Now I can see it. Yes. Thank you.
Okay, right. Good then. Thank you. So so like I was saying on the migrating of from auto scalar um to carpenter. So this will like this particular documentation. I think let me confirm on my slide. Okay, yeah. So I actually added it. It's very good, and I think the only part that I think that was not added to the documentation was it the SQS? Yes. Okay, yeah, it's there. I think there was a particular part that was not there. But anyway, so we'll be running through some of these steps. So I already like did a few pins on autoscaler earlier. So I already explained that that is like our traditional way of doing things of scaling. So now that it's currently like running, so if you see this now, you can see that cluster autoscaler is currently running. So we're gonna have to um, see how we can now migrate this to a carpenter. Right. So I already have like some if the carpenter folder written in I'm currently using Flux. So yeah, we are using hem releases or YAM file for all of these. So great. Um let's export this. Let me confirm the name of the should be scalable demo. So there's really no way I'll be able to like share. I'm trying to share. There's no way I'll be able to share both the um, what's it called right now? The where presentation I'm currently using, but let me I could do that and show my terminal as well. I think I should be able to split my screen, right? But anyway, so thank you. So now that we exported, we have that on, then the next thing would be that after usually as per the documentation, it was stated that okay, you can actually have carpenter namespace on the cubes and on the cube system namespace. So we need to like set other variables that are needed. Give me a minute. Okay, so I have less than 10 minutes. Okay, all right, so we might not be able to run through all of these in 10 minutes. Give me a minute. So I think I'll just go back to the previous slide. them and explain what we should do there. Ooh. All right, you can see the documentation that we will be using, that I was actually running through some of those steps on the on my terminal. So I have less than 10 minutes, so I can't run through all of this. So, but let me run through some of these steps that are currently like here and explain what is going to be happening for you. So the after setting the variable I said earlier on my terminal, cube system namespace cluster, and you set other environment variables that are needed. For example, the all of these that was stated here: AWS partition, your OHI DC, which is on this one. We just need to copy it from here, and you have your Kubernetes version and the Alias version as well. So you create the IAM role and the inline policy. This particular step is very, very important in order to be able to use to be able to provision these rules are going to be used for the node provisioning that will be managed by the carpenter, including the controller it's going to be using. So the node role that will use this policy for carpenter. So you already have this run through. So we're going to be attaching it. We attach, you run this command to attach. Since we already set those variable at the top, this ones here, yeah, it will be easier. So you just need to like run those commands here, and it will actually, so it will just go with the when you are actually going through your I am console, capital node rows or cluster, maybe for example in our demo here, you can see that we are using scalable demo. So that is what it's going to look like. So then we need to like create the other okay, this is the second row that you'll be needing. This is the policy, right? And it will be requiring an service account required for this what's it called, the carpenter. Then you can create a tag, add tags to the subnet. So just for, it's very important to add most of this tag to this notebook subnet so that carpenter can know which subnets to use. So right, and after you have done those, you need to like update the fig map, and this is where those nodes will now be using those IAM rule that you have created to like join the cluster. So because if you don't modify this config map, it's not going to like really like complete those necessary steps that you need to do. Also, yeah, I remember. So I was stating that there was something that was really not stated on this documentation, which was you installing the Carpenter CRD. You need to like install the Carpenter CRD first of all, and depending on how your infrastructure is like, if you're actually using a maybe for example you're using flux cd as your githubs, that means like you need to like define those yam files or your particular files for the crd. So people have those crd files on their infrastructure repo. So you can actually have it there, or you can manually just apply it to your cluster depending. But there's some people in today's modern world, many things are now being in Git or in GitOps where you have most of these things, you see them and then can up. So after you update the config map, and I'm trying to like rush through because I think I have less than 2 minutes. So confirm again. Yeah, okay. So so after you've run through and you have your SQL IAM roles, you have updated the config map, you have them. So depending on your step earlier, if you're applying them manually or you're going to be using a GitOps or you're actually having those files dated. For example, in my own case, uh, let me just move my screen a bit any one more time. So in my own case, you can actually see that we have like our EC2 node class file, YAM file. We have our M release file. So you need to state what version of Carpenter you want to use. I think the one of H1. So and also M repo is actually installing Carpenter through M. So these are files. So like I said earlier, it depends on what your how your infrastructure is like done. If you guys just apply things manually by just running the commands, fine. But if you need to see them, because most times so people want to like have them on their GitHubs or on their repo, infrastructure repo, so that they can see the versions of what has been updated by different teams. So and you can also have, so this is where we now have our node pool. You can state your what's it called, what sizes that carpenter should use if you have anyone, and all of that. You can also give me a minute. So this is the M repository as well, where you have to call it. So you can also either manually install it, or you can actually or either call the M repository of the carpenter itself to run through. So these are different ways you can actually do that. So thank you so much. Let me run through. I can pick up some questions now. You can't see your screen now.
Okay, thank you, Falashade. I was just about to bring it up now. You can't see your screen anymore. I've sent you a message, but um, if there's something important you want to show us, maybe we can take the remaining 2 minutes before.
Is my screen still visible now?
No, it's not. It's not visible.
Oh, why is this happening? He's always calling, but anyway, it's at the end already. So
No, I dropped the message. I guess you didn't see the message, but you can see your
yeah,
screen now. Anyway.
okay,
So maybe you
okay.
want to run us through the last five
Steps
minutes.
I missed. Yeah,
Okay.
okay. All right. So I was saying that this is the EC2 node class um what's it called? Files that we have written on the Flux. So you can actually, in my own case, we are using Flux CD as our GitOps, and with AIM and what's it called, EKS. What else am I missing here? EKS with your Carpenter and your EC2 instance and node pool are actually being defined on the GitOps, or I mean on your repository infrastructure repo. So you can actually state or what EMI family you want to use. For example, maybe EL2. I think we are now using EL 2023. So this is like a demo. So you can actually have 2023. I think that should started being available for a few years now. So this is like a demo, but you can actually use 2023, which is like the latest, and you can see each subnet. And when you are running those command of the adding of the tags to for Carpenter to know which particular one. So I was also talking about, I mentioned about the what's it called, M repository, where you can either manually call it, or you can also define it on your infrastructure repo as well. So the EC2 instance, EC2 node class, and the node pool are very important. So this is where you actually define your HPA, your memory resource limits, and the memory and the CPU on your HPA. So things that are being defined here on your repo, I mean your infrastructure repo, are very important. And as Carpenter will be looking at this, depending if you're using Flux. I think some people use Argo CD, but I've not actually used that part before. But um, as you have all of these things defined, that is how much you can actually like manage. And Carpenter can use all of these information, those things that you've actually like defined, and deploy them. And it's now picked up from all the EC2 instances. Like we already have Capita has their capacity to use over 700 EC2 instance type. So there is really like no real limits exactly or when it comes to Carpenter, because it has the capacity, that intelligence to be able to like select from the best. to look at your workload depending on what services, if you're using microservices, or to define what is best for your workload at that particular time. So in case of when you have spikes or you have traffic on your website, it kills as much, look for the best and create more node groups. And when things goes down to normal, it just goes back and drain those node groups. And after draining them, it cuts costs. So it means that your auto scaling is only used when it's actually needed, which helps with the cost expenses as well for company. So yeah, I think that's would like wrap up what I was previously saying. Over to you, Christian.
Thank you so much for Lashade. I personally I've learned a lot from this session. I think one thing that's stood out to me is how you're using Carpenter to reduce cost without sacrificing performance, in scaling your node and all of that. So I think this is a service that I'm really excited to start trying out and see how it works. So I don't know about you guys, but my notes is filled. I've taken a lot of notes here and things I want to try out and read more about. So thank you for Lashadi. This session was really, really impactful. So now we're going to be taking questions for the next 5 minutes. I'm guessing you've also been following along. I know that at some point, Falashade couldn't really do the lab, but I'm sure that you've got one or two things and you have questions. So please, you can start dropping your questions on the chat so that Falashade can take your questions. Um, Hi, Kadiri, Emmanuel, Ashira. Let's get your questions. Alright, let's get your questions. So you can start dropping your questions. I'm not seeing questions on the chat yet. Okay. Okay, so while we wait for the questions to drop, we're going to be having a Kahoot session shortly after the question session, and I hope you're excited as much as I am. And yes, there's going to be a winner, of course, and I hope you win. All right, but let's take questions first. Any questions? Do you have any questions from anyone? Okay. All right, Folashade, they don't have questions for you. It's like you did an excellent job in the explanation.
No, I actually don't think so. For me, it's either two things. It's either people are listening or they get it, or it is they are not listening at all.
So I want to
But
assume they were listening and they understood it
like the
perfectly.
section that you can still like go through it. And I think I'm not sure the way like share the slides with people after, because I think maybe they can go through the documentation that was stated and maybe go through the repo as well. And yeah.
All right, that's fantastic. Thank you, Folashade. So the slides will be shared. And then, of course, if you have questions, I'm guessing that Folashade is available maybe on LinkedIn or on her socials. You can always reach out to her for, you know, to just rub minds on any issues you're having with Carpenter. Now, Carpenter is new for load scaling, and I'm really eager to also try out some things as well. So I'm also going to request for the slide. So thank you once again, for Lashade, for this really insightful session. It's so bad that we had just little time to look at it and we couldn't really get into the lab session, right? But because of time, we had to stop here. All right, so it's time for our Kahoot session, and I hope I have people here ready to participate. And you're going to show us your that you've been paying attention to everything we've been that Folashade has been saying, right? So get ready for the Kahoot session. So I'm going to be sharing my screen now, and I'm going to also just drop in a link to the cloud session for us to join. Just give me minutes. Mm-mm. Okay. All right. Please just give me a minute. Let me just get the link. All right. So we're ready to get started. I want us to join. I hope you're ready. Waiting for you to join. Right? So we're waiting for you to join. Please confirm you can all see my screen. I don't have people here. It's like you guys are not excited to win. We're waiting for you. Okay, Emmanuel. So Emmanuel, we're waiting for you to join. We're waiting for you to join the Kahoots. All right. Where is everyone? right, so we're going to move on now, and we're going to. Oh, someone has joined. Hi, Max, right? Okay, so I have Max here. Max seems to be my only player. So Max, you're automatically my winner, right? Okay. If I have one more person join, then we can still go ahead with the Kahoot session. Because if I have someone join in the next 2 minutes, else I would have to declare Max my winner and just end the Kahoot session. So I'm going to give 2 more minutes for one more person or any other person to join us and compete if you want. If you want to win my prize, right? Okay, so 1 more minute, and Max would automatically be my winner. 1 more minute. Okay, so no other person is joining. So Max, thank you so much. You're my winner for this Kahoot session, and I just want to thank you for joining. Right, we'll have to just declare you the winner. All right. So with that, I want to thank everyone. Thank you, everyone. Thank you, Folashade. Thank you, Folashade, for coming on board. It was nice learning from you, and I look forward to more engagements with you and the AWS Cloud Security West Africa. And everyone that joined the call, thank you so much for joining. Thank you for making it interactive. And don't forget that this series is every weekend. So we've collated some series of interesting topics, and that's going to run for a while. So you want to be here next week. The registration link for the next series, which is going to be happening next week, is going to be shared. So please register, attend, and learn. All right. So thank you so much. Thank you for Lashadi, and thank you everyone. And I hope you have a good evening. Okay. So bye everyone.